So, good afternoon, sir. My name is Steve Daniel Lalantacon Mingilian from BSMT3 Betelgeuse, and this is my video explanation on CO1 assessment. So, in task 1, complete the parts and of the turning circle of MB Crystal E with a right-handed propeller in normal full loaded condition with maximum rudder angle full speed RPM. So, in this illustration, I have here the illustration of starboard to port. So we have here the approach zero helm and the initial movement to starboard, the advance, transfer tactical diameter, the maximum force, maximum transfer 180 degree, drift angle, and path of ship's center of gravity. Next, we have here the illustration of port to starboard. We have here the approach course, advance, rudder execute, the transfer, tactical diameter, change of heading, path of midship points, turning radius, drift angle, 180 change of heading, and the 90 degree change of heading. In this next image, we have here the turning to port side and turning to starboard side illustration. So normal full loaded condition with maximum rudder angle, full ahead RPM. So my answer in task 2 is the appropriate action for the illustration is to anticipate and understand the countermeasures according to the wind and current affecting the ship's course. For the illustration, I will correct the ship's course to starboard side to avoid to be aground and maintain safety of navigation and to steer and the ship to its correct ship's loading. In task 3, human factor. A delay in the time between your given order and the execution of the order will affect how you intend to move your ship. This is caused by the human factors because the individuals you are ordering may have different responses depending on their training and daily to perform the job, or that orders have to be relayed by an officer to helmsman, which is a bad practice that should be avoided, so that the coming officer should be able to give his order directly to the helmsman. So we have here the task 4, question number 1. So why and how does squat effect take place? So the ships float in a water because of one reason: there is no mid force acting of the ship, but all their factors are equal and opposite in nature. Two of these forces that act in opposite directions are gravitational force and buoyancy. Force of gravity like to sink in the ship, and force of buoyancy likes to make it afloat. Force of gravity continue to sink in the vessel until force of buoyancy becomes equal to force of gravity. So in question number 2, what are the factors that affects the squat? So here are the factors. Ship speed or man factor. Squat is directly approximately proportional with the speed squared. Depth of water inversely proportional. Confines of the channels inversely proportional. Block coefficient, ratio of immersed volume of the ship relating to the waterline length, breadth, and draft, directly proportional. Blockage factor, immersed cross section of the ship's midship section divided by the cross section of the canal or river, direct proportional. So in question number 3, how do we know if the squat will result in forward trim, aft trim, or no trim? So the bow of the ship will not obstruct in the water flow as much as the mid and aft section of the ship. This is because of the ship's shape of the bow. In this case, the effect of low pressure will be aft of the midship. This will cause the stern to sink more than the bow and will result in trimming aft because of squat. The tendency of the bow is to obstruct the water flow is related to the block coefficient of the vessel. Block coefficient of the vessel also defines if the vessel will squat bodily by stern or by bow. So in last question in task 4 number 4, what are the signs that slow vessel is experiencing a squat? So here are the signs. So ship's steering becomes sluggish, that is, it becomes comparatively difficult to steer the ship. Engine RPM will decrease to compensate for the load of the engine. The speed of the ship will decrease. I have experience with 0.7 meters UKC, vessel moving at full ahead, only making 6 knot GPS speed. The ship may start to vibrate, mud showing up around the ship's hull, vessel rolling and pitching reduced, and the last is turning diameter of the vessel increase. It can be cost as much as twice so that in open sea. So that's all, sir, and thank you.